How are stars formed? The formation of stars is a complex and fascinating process that takes place over millions of years. Stars are formed through a process known as stellar evolution, which occurs within large clouds of gas and dust called nebulae. The study of stellar evolution helps us understand the birth, life, and eventual fate of stars in the vast expanse of the universe. Here is a simplified explanation of how stars are formed. 1. Nebulae. Stars begin their formation in regions of space where nebulae exist. Nebulae are composed mostly of hydrogen gas, along with traces of other elements. 2. Gravitational collapse. A disturbance, such as a nearby supernova explosion or the gravitational influence of a passing object, can trigger the gravitational collapse of a nebula. As the cloud contracts under its own gravity, it begins to spin and flatten into a rotating disk. 3. Protostar formation. Within the contracting cloud, a dense core, called a protostar, begins to form at the center of the disk. This protostar accumulates matter from the surrounding cloud, growing in size and density. 4. Nuclear fusion. As the protostar continues to accumulate matter, its core becomes hotter and denser. When the temperature reaches about 10 million degrees Celsius, nuclear fusion begins. Hydrogen atoms in the core fuse together, creating helium and releasing an enormous amount of energy. This energy generates the star's heat and light. 5. Main sequence. Once the nuclear fusion reactions stabilize, the protostar becomes a main sequence star. This phase is characterized by a balance between the inward pull of gravity and the outward pressure created by the fusion reactions in the core. Main sequence stars, like our Sun, spend most of their lifetimes in this stable phase. 6. Lifespan and stellar evolution. The lifespan of a star depends on its mass. High-mass stars burn through their fuel quickly and have shorter lifespans, while low-mass stars can burn steadily for billions of years. Eventually, stars exhaust their hydrogen fuel, causing changes in their structure and behavior. 7. Stellar death. The exact fate of a star depends on its mass. Low-mass stars, like our Sun, expand into a red giant, shed their outer layers, and form a dense core known as a white dwarf. High-mass stars, on the other hand, undergo a supernova explosion, leaving behind remnants such as neutron stars or black holes.